sometimes we're going to divide scientific notation. And here's an example of how to do that. Here I have 7.0 times 10 to the 7th divided by 2.8 times 10 squared. What I'm going to do is I'm going to use my properties and split this up into two fractions. 7 over 2.8 times 10 to the 7th over 10 squared. So now I can divide 7 by 2.8 on my calculator, and then I can use my exponent rules since I have the same base over here with 10 to the 7th and 10 squared. So 7 divided by 2.8 is going to give me 2.5, and you can use your calculator to figure that out. And then 10 to the 7th divided by 10 squared, I'm going to use my exponent rules, and I'm going to subtract my exponent, 7 minus 2, which gives me 10 to the 5th. So I end up with 2.5 times 10 to the 5th. Now notice in this example, our answer comes out in scientific notation, so that is our final answer. Let's look at another example that's a little harder. In this example, I have 7.164 times 10 to the 8th over 9.95 times 10 to the 3rd. Again, I'm going to split this up into two fractions. And that way I can just divide my two numbers together on my calculator, and then I can divide same bases by subtracting their exponents. So when I divide 7.164 by 9.95, I end up with 0.72. And when I divide 10 to the 8th by 10 to the 3rd, I subtract my exponents and end up with 10 to the 5th. So next, I need to change 0.72 into scientific notation. So the way I do that is like we always do. I move my decimal over one place so that I have just the 7 in front of the decimal. And since it was a small number, less than 1, that one place shows up as a negative exponent. Another way to think about it, so first we're writing this as scientific notation. Then we're going to multiply the 10 to the negative first times the 10 to the 5th. So we end up adding our exponents to get 10 to the 4th. So 10 to the negative first plus 5 will give us 10 to the 4th. So another way of thinking about this is when I change my 0.72 into 7.2, I made it one place bigger. And so to keep 7.72 equal to 7.2 times 10 to some power, I have to make that power 1 power smaller. So I end up with 7.2 times 10 to the 4th. Let's look at another example. Here I have 2.24 times 10 to the 6th divided by 7 times 10 to the 3rd. So what do you think we should do first? Right, we should split these up into two different fractions. And I'm going to divide 2.24 by 7 on my calculator. And then I'm going to divide 10 to the 6th by 10 to the 3rd, which means I will subtract my exponents. So 2.24 divided by 7 is going to give me 0.332. And then when I subtract my exponents, I end up with 10 to the 3rd. Now, 0.32 is not in scientific notation, so I'm going to change it into scientific notation, which is going to give me 3.2 times 10 to the negative first. Now I need to multiply my same bases, so I use my associative property here and multiply my same bases. And when I do that, I end up adding my exponents, negative 1 plus positive 3, which gives me 10 squared. So my final answer is 3.2 times 10 squared. That other way you can look at this is I started out with 0.32 times 10 to the 3rd. I had to make 0.32 bigger one place, so I ended up making my 10 to the 3rd smaller to make up for that by one place. So that's another way to look at it.